Well, first of all, for the pre-treatment of the sample, we have our substrates, which is silicon tin gold. Here are the substrates. As a pre-treatment of them, the substrates should be cleaned before placing to the electrolyte, because contaminants from the previous processes, the manufacturing processes, can remain on them, and as a final step, they are covered with resin. So, as a first step, to dissolve the resin, we place our substrate in acetone and remain it there for a few minutes, or put it in sonicator. And as a second step, to dissolve the acetone, we should put the sample in alcohol, which is generally isopropanol or ethanol, any type of alcohol. And then, as a last step, we rinse the sample in molecular water, which is highly distilled, pure water. And before placing it in its holder, we dry it by air to remove the water from on top of it, and then we place it in a crocodile, a holder, which connects to the working electrode, and then wrap it around to avoid the electrode's contact with the solution, and then we have our sample prepared, and then we can step into the electrode deposition process.
So this is our electrode deposition setup. We have a three-way electrolytic cell. Here we have our counter electrode where we attach our anode. The anode can be either consumable, so that means it's composed of the metal that we are trying to deposit, so we have a constant replenishment of the metal ions in the bath. Or it can be an inert anode which does not react, such as in our case where we have a platinum wire. Here is our working electrode. Here we attach our sample, and this is where the electrode deposition will take place. We can now place it in the bath. And here we have our argon gas supply. This is used to deaerate the bath, which means we use it to release any gases that have been dissolved in the bath, such as oxygen. And this finally is our reference electrode. It's a silver chloride electrode, and it is used to always check what the potential is, because we cannot directly measure it. We always measure it in relation to our reference electrode, which has always a fixed potential. And this is, we have inside the bath a magnetic stirrer. This is used to provide circulation to the bath, and we can set the different speeds from here. And we are ready now to start the software. The current will be supplied by our potentiostat galvanostat, and from the software we can set all our electrode deposition parameters and begin the process.
In order to initiate our experiments, we first insert the parameters of the experiment in a certain software. We can carry out galvanostatic experiments or potentiostatic experiments. In potentiostatic experiments, we may apply a certain potential to our bath and then measure the current density. In the other one, in galvanostatic experiments, we apply a certain current density, a static current density to our sample, which is the current per area, and then measure the electrode potential. In order to initiate the experiment, we insert the current that we are going to apply, and then we insert the time, which is the parameter of the thickness. And upon finishing our experiments, we take our sample from the bath. We can see the color of the coating here, and then we rinse it again in molecular water to remove any kind of residual solution to avoid contamination in our final product. And that's how a classical electrodeposition process product looks like.
So here we have our plated sample. We are ready to remove the Teflon tape now. So we unwrap it, and here we can release our sample. Here you can see the difference between the coated and uncoated side. And we are ready to dry it with our nitrogen gas. And now our sample is ready for storage and analysis.